Imagine storing power from, say, huge offshore wind farms, but not on land. Instead, picture giant concrete balls just sitting deep on the seabed.
It's quite a visual.
Right. And that's basically the concept behind a project called StEnSea. Today, we're going deep on how this underwater energy storage actually works and, what potential it might have.
Yeah, we've looked at quite a few sources, project reports, comparisons, expert takes on, well, is this actually feasible?
So our mission for this deep dive, give you a really clear picture of StEnSea, the tech, the good points, the bad points, and what it could mean for energy storage.
Okay, so the absolute core idea borrows from something pretty familiar. Pumped hydro storage.
Right, the classic setup. You have a reservoir up high, one down low, use cheap electricity to pump water uphill.
Yeah, and then when you need power, you let it flow back down through turbines. Simple potential energy storage.
So how on earth do you do that under the sea? Where's the uphill?
Well, the uphill, or the upper reservoir, is basically the entire ocean above it, the deep sea itself.
Okay.
And the lower reservoir is one of these specially built hollow concrete spheres, anchored way down, maybe 500, 800 meters deep.
Hollow concrete spheres, and how do you charge it?
Right, so to store energy, you use electric pumps, pump turbines, actually to force the water out of the sphere.
Creating a vacuum or near vacuum inside.
Exactly. So now you've got this huge pressure difference between the empty inside and the immense water pressure outside. That pressure difference is the stored energy.
Clever. And getting the power back, just open the tap.
Essentially, yeah, you open a valve and the outside seawater just rushes back into the sphere because of that pressure.
And that spins a turbine as it goes in.
Precisely. Turbine connects to a generator, makes electricity, sends it back to the grid.
It's a neat concept. I see it originated back in, 2011? Professor Schmidt-Bucking and Dr. Luther.
That's right. And it moved from just an idea to a proper research collaboration involving the Fraunhofer Institute, IE, and Hochtief AG. They got some German government funding, too.
And wasn't there a small test already? Like a proof of concept?
Yes, absolutely crucial step. In 2016, they put a smaller one, about 3 meters across, into Lake Constance.
Lake Constance. So freshwater, not the deep sea yet.
Right, but deep enough to test the principle. It showed that storing and releasing energy using this underwater pressure in a hollow sphere actually, well, works.
Okay, fast forward to now. They're planning a much bigger test off California near Long Beach.
That's the next big leap. A real-world ocean test. They're partnering with a U.S. company, StEnSea.
StEnSea, right. They do 3D concrete printing. That sounds interesting.
It does, and also Plugger Industries for the underwater pumps. The plan is a working prototype by late 2026, I believe.
And this one's much bigger than the lake model.
Oh, yeah. 9-meter diameter sphere. Weighs about 400 tons. Designed for 0.5 megawatt of power, 0.4 megawatt hours of storage.
Still a prototype, but getting substantial. And StEnSea might actually 3D print this giant concrete ball.
Potentially. Or maybe combine it with, more traditional methods. They'll build it there in Long Beach.
So what's the big appeal here? Why go to all this trouble putting concrete spheres on the seabed?
A major factor is long-duration storage. We're talking hours, maybe even days. That's a huge deal for renewables like wind and solar that aren't, constant.
Unlike batteries, which are often more for shorter bursts, right?
Generally, yes. Plus, putting underwater avoids a lot of the land use issues and, frankly, public acceptance problems you get with big land-based pumped hydro. Less ecological impact, potentially.
And the potential scale seems vast. You mentioned GIS analysis.
Yeah, studies identified suitable spots off coasts like Norway, Portugal, the U.S., Brazil, Japan. Even deep lakes or flooded mines. The estimated global potential is huge, something like 817,000 gigawatt hours.
Wow. And you could imagine putting these right next to offshore wind farms.
That's a key synergy. You could potentially share the expensive subsea cabling infrastructure, cuts down costs, helps manage the variable wind power right where it's generated.
Plus it's modular, right? You can add more spheres if you need more storage.
It's exactly. Scalable. You build a farm of these spheres to match the need.
Okay, but sticking big concrete things on the seabed. What about marine life? Environmental impact.
They seem to have thought about that.
Yeah.
The main materials, steel and concrete, are pretty inert. They plan to use fine mesh grids to keep animals out, and the water flow speed when discharging is designed to be low. Minimize disturbance.
You mentioned a specific depth earlier, 600 to 800 meters. Why that range?
It seems to be the optimal trade-off. You get significant water pressure for good energy density, but it's not so deep that you need incredibly thick, heavy, or expensive special concrete for the sphere.
Ah, okay. And it allows using more standard underwater pump technology.
Right. It keeps things within the realm of, let's say, existing marine engineering capabilities. The actual capacity depends on the sphere size and that water pressure, obviously.
What about efficiency? Pumping water out, letting it back in, you lose some energy.
Always. But simulations for a small park of spheres suggest a round-trip efficiency around 75 to 80%.
That's quite respectable, actually. Comparable to traditional pumped hydro.
It is. And the concrete sphere itself should last a long time, maybe 50, 60 years. The pumps and turbines, like any mechanical system, would need replacing maybe every 20 years or so.
Okay, the economics. Big projects like this need serious funding. How does StEnSea stack up?
Well, it's got government backing from Germany and the U.S., which helps. Early cost estimates are around 4.6 cents per kilowatt hour stored.
Which sounds competitive, depending on the market, I guess.
It could be, yeah. The investment cost estimates are out there too, roughly 1,300, 1,400 per kilowatt of power, and maybe 160% per kilowatt hour of capacity. Profitability really depends on how many you build together. Energy price differences, arbitrage, and how often you cycle them.
How does it compare head-to-head with other storage? You mentioned batteries, traditional pumped hydro.
Compared to traditional pumped hydro, its big plus is location flexibility, not needing specific mountain geography. Compared to, say, compressed air storage, it's likely more efficient and doesn't need fossil fuels for reheating, like some CAS systems do.
Yeah. And batteries.
Batteries are great for fast response, but large-scale, long duration is still pricey, and lithium-ion has supply chain concerns. Flow batteries are another option, but they can be bulky. StEnSea aims for that large-scale, longer duration niche.
It's interesting. I remember reading about an MIT concept a while back, also using concrete spheres underwater for wind energy storage.
Yes, there have been similar ideas floating around. Shows it's a concept people see potential in. The MIT idea even suggested using the spheres as anchors for the turbines, though deploying enormous spheres like that poses challenges.
Right. So summing up, StEnSea is a really innovative take on large-scale, long-duration storage. It tackles that intermittency problem for renewables like offshore wind head-on.
Absolutely. And this California test is going to be critical. It's the real make-or-break moment to see if it scales up effectively and economically in the ocean environment.
It really makes you think, doesn't it? We're always looking up for energy solutions, solar, wind.
But maybe a big part of the answer lies beneath the waves, using the deep ocean's natural properties, like pressure. What other ways could we use the planet's environments, perhaps in unexpected ways, to solve these energy challenges? It's a fascinating question.
This has been a deep dive from Le Podcast de Philippe.
And if you found this look at underwater energy storage interesting, maybe help us out.
Yeah, please do help us reach 1,000 subscribers. We'd really appreciate it.